Okay, last video for 2.2. Once again, let's talk about average rate of change, or I should say rate of change. Remember when we talked about rate of change, we have two types. We have average rate of change, which is your slope formula. And now you have instantaneous rate of change, which is the derivative. Those are the two types that we have. So let's do an example of each just to refresh. We have this equation. It's the same equation for both problems. First, I want to find the average rate of change from here to here. So here's my x1, there's my x2. So I want you to practice this one. You should know how to do this on your own, but a quick refresher if you don't. I need to plug both of these into my problem, into my equation, and that will give me y1 and y2. And then I plug them into my slope equation. So pause the video, try that part out on your own, and then come back. Okay, welcome back. So this is what you should have gotten. Plug both in. You get 1020 and 27,060. Plug them into your slope formula, and that can be your answer, but if you want to simplify it, you should have also gotten that. Now we want to find the instantaneous rate of change when x equals 10. Instantaneous rate of change means we're looking at our derivative. So I want f prime of x. So I want you to try this one out on your own. Try to find the derivative by yourself, and then you're going to plug 10 in to the derivative, simplify it, and that's your instantaneous rate of change. So pause the video, try that one. Okay, here you go. You might have gotten a little tricked up on the derivative this time, so let's go over it. If I want to find the derivative of the first half, I take the 3 in front and I minus 1. That one you should be pretty used to. But this one, remember I don't affect the 2. That's my scalar multiplication rule. The exponent is a sneaky 1. Even though it's not written there, it's a 1. So I'm going to take the 1 down in front and then do the exponent minus 1, which when I simplify that, my 2 times 1 gives me 2, and my 1 minus 1 gives me x to the 0. But anything to the 0 power is just 1. So then it simplifies to this. So anytime you take a derivative of a linear, so if I had like 5x, the derivative will just be the number in front. That x is going to end up being to the 0, and it'll go away. So then I plug in 10, and I get 302. So that's all for today's lessons. Go, and when we come to class, we'll try out our flipped classroom for the first time, and we'll see how we do.